I'm going to show you how to create Sierpinski's triangle and do that in processing, which is a variant of the Java programming language. So this is what your end result should look like. And just so you, if you're not familiar with this fractal, this is basically a series of triangles being halved and then put inside the original triangle. And so this looks like it's a bunch of triangles pointing down, but it's actually, that's the white spaces between the triangles. They're actually all pointing up like this. And then there's going to be triangles inside of each of them. This is kind of what the progression looks like. Start with this one, then you have 1, 2, 3. So that white in the middle is actually the empty space. Then your end result is like that. I'm going to share some source code with you, but let's go over kind of the basic setup here. So we have, I just arbitrarily created a start size for the sides of the triangle, and I just made this X and Y. Since in processing your 0, 0 for the XY is in the top left-hand corner, I started us on the Y down at the bottom so we can draw up, right? And the draw method's just going to be left empty. That setup's fine because that will be able to contain our triangle. And then I just made this triangle method that's going to be our recursive method, because in fractals it's all about recursion, and you just keep calling this and tweaking something. In this instance, we'll be tweaking the side and the start position for our X and Y coordinates. So let me just show you how quick we can get up and running. Oh, I'm not going to need that show true. So our first call is going to be right here, where we're going to send these variables to our triangle function, right? So we're starting our starting positions. And so in the rest of our programming is going to be right here inside this triangle. And what it's going to look like is, so we need to just set up our X and Y position. So when in processing, you actually make a triangle with this triangle function. And so you need to have 3 points. Your starting point, then where you're basically drawing a line to the next point. And then this is the start of the line for the, this is the starting point for the next line that's going to end here. And then it kind of connects this first one to that one. So you can kind of see this as, you know, being, let's say like right here. And then this one would be up in here. And then this one would be down here. And then that would connect, right? And so let's make those points for that. And so let's say in X, so we already have X and Y starting. That's going to go right there. So let's say X2 is going to be equal to X plus side divided by 2. And, you know, that kind of makes sense. If we look at this triangle, that's this point here, which is going to be halfway through here. So that's why we're saying X plus side divided by 2, right? So because this is X, and this is side, and we're going to divide by 2. We're going to be right in there. So just so you understand the background behind that, and then we'll do the same thing for Y. But Y is going to be different because that's going to be equal to and basically side. Just basically you're going to subtract side from it, because remember, you know, this is, we said that our Y position was 400, and in processing you go up to get closer to 0. You're actually subtracting, right? So it's a little different than your typical graph. And so we need to actually subtract side to bring our Y up to here, okay? I know I'll show you later how you can do this as a perfect unilateral triangle, which I guess the Sierpinski triangle is typically a unilateral. This is going to be a little off than unilateral, but it works. It'll still look nice for us. All right, so then let's look X3 is going to be equal to x plus side. And again, the reason for that is, so here's x, and the x3 is going to be over here, so you just add side to it, and it's going to go down there. So that explains that. Oh, and that's an int. And the y3 is, it's just going to be equal to y, because it's on, here was our original y, here's the last y, so it's just the same, it's on the same axis, the same plane. All right, so that all looks good. We'll make a stroke here, and now you can do this whatever you want. I'm going to do a blue stroke. All right, so it's RGB, and so the blue is pumped up. All right, and then we have our draw our triangle. All right, and then we have to change things before we give our call back. We have to make everything, our big change is we're going to say side equals side divided by 2. And then we can, let's just say if side is greater than 200, and we're going to keep calling this triangle, or actually we'll say try, which is the name of this method. And we'll just throw back in x, y, and side. And so side has already been divided in 2. So now that's going to throw it back in here. And actually here, let's take this down to 10, let's say. And when we run this, you'll see I have to press the mouse key once. It actually drew these triangles. Doesn't look like much yet, but because we need to make 2 more recursive calls, we're going to say try x plus side, which that's going to take us right into the middle. That'll take us right here, and we'll start drawing a triangle over here, right? And so y is going to be the same, and then side. Let's see, let me run that. All right, so we're getting close. We're getting close. That's it, all these different triangles inside of there. And then let's do that. The third one now, we have to make this red one here that's going to be on the top. And it should start looking like something. Actually, this should be Sierpinski's triangle when we finish this. Let's do x is just going to be, x is going to be plus side divided by 2. Then that's because where it's starting is up here, which is about, you're going to be like you're over on the x-axis about 1/4, because this is a half, and we're going to start like right about here to draw that triangle. Okay, so that's why we already halved it. So now we're halving it again to get it to be 1/4. Right, we halved it right up here, and then we're going to say y minus side. Actually, I'm not sure why I put that in parentheses. And then the side. That should do it. Let's see. I don't know if I messed anything up or not, but try to run it. Yeah, there it is. Sierpinski's triangle. And you can tweak the this here. We'll go down to like 2. We should see some crazy little triangles now. Yeah, it starts filling. It's almost too close to each other. They're filling in the spots, but it's pretty cool. And like you can kind of see its progression. Like if you did this at 200, that's not even enough to do it. Let's say 190. Now see, those are original 3 triangles that are drawn, right? And it's pretty wild how quick it gets down to all those triangles. So there you go. That's Sierpinski's triangle. Hope you found that interesting. I will publish another video relatively soon that shows you. So this is actually not a true unilateral triangle. Like this line here is actually shorter than these two lines. It was just so much easier to make y minus side be the value, so I just took that side and went up. But basically, we're coming at a 60-degree angle, so this line is going to take a little longer to get to that, that 400 value that we have here. So I'll show you, though. It's a pretty quick fix. I'll show you in a future video for anyone who's interested. All right. Thank you.